All right, so welcome, everyone. It's a great pleasure to speak in front of you. I'm incredibly excited. You cannot even imagine how excited I am just right now. So basically, I'm going to talk about rethinking enterprise architectures with Node.js. And the enterprise word is incredibly important here. But before we start, I would love to introduce myself. So my name is Kamil. I came from Poland. Daily, I work as a software engineer at Scalio. We are a development design studio based in San Francisco. Primarily, we develop cutting-edge software for both top companies and startups. Also, I'm the software consultant and the trainer. You can find me on Twitter using the depicted Twitter handle, and certainly on the GitHub. Besides, I am the creator of an open source project called Node.js, which is basically the fastest rising framework written entirely in TypeScript for Node.js. We are like Vue or Webpack, but a little bit younger, and in terms of the backend apps. And I have to update this slide at least 3 times already, just to make sure that the number of stars match the reality. So luckily, yeah, we are growing quite fast. So, all right, let's start with a brief note about Node. Do we have Node.js developers here? Please raise your hand. Oh, a lot of people, quite a lot. Great. So, for the rest of us, just to make sure that we are all on the same page. In general, Node is a JavaScript runtime built on top of Google Chrome V8 engine. It allows us using JavaScript outside of the browser, for example, in the server-side apps. And even though Node by itself is an incredibly interesting topic, I will not dig into the technical details, neither the events loop, event-driven architecture, nor asynchronous input-output capabilities. The idea for this talk is a little bit different. So instead, I would like to cover different areas that concern all of us as well, but we actually don't think about them too much. So the first question is, what is Node? And why? The Node is definitely a remarkable, striking tool, right? However, let's think for a while. What terms describe it best? Obviously, in a positive context. What makes it so exceptional, extraordinary? And the first trait that I would like to emphasize is the language. So I guess that we all love JavaScript here. This is the conference mainly focused on this language, so we at least enjoy writing code using this language. Anyway, JavaScript, the same language on the server side and the client side, gives us a couple of benefits. The first one is productivity. Our productivity increases several folds. The learning curve is gentle, so we've got an ability to smoothly exchange the knowledge within the team, between the client, between the front-end team and the back-end team, right? That makes Node easy to learn, simple to absorb, and absolutely it accelerates the learning process. Another point is reusability. Reusability makes sharing code between platforms possible. Thus, we are making apps efficiently. We get rid of redundancy, inconsistency, for example, by keeping interfaces cohesive across several projects, right? And the last but not least, in terms of the language, is a community, right? This is a conference. You see how many people is there. So a solid community support, rich ecosystem, a wide range of useful libraries that solve a bunch of various problems out of the box. So basically, we don't have to care about them. We can just pull existing library from the NPM registry or directly from the GitHub repository. So we are not wasting time. We do not have to reinvent the wheel. Moreover, JavaScript, according to the latest Stack Overflow survey, is the most popular language. We've got almost 70% So we should be really proud of it. Certainly, you are not the most loved language like Rust is, but it's still a quite good achievement, right? So regardless of all this stuff that I've just mentioned it about, right, productivity, reusability, today I will mainly focus on a very essential advantage known as a simplicity, which in fact is very crucial in terms of the enterprise applications. So there is a such well-known quote: the simplicity is prerequisite for reliability. And I suppose you all agree with that. Although the question is, what is simplicity? What is simple and what is complex, and how to differ them? When something becomes too complex, so we should think about simplifying it. So we have a lot of articles that say Node is simple. Where does this theory come from? Let us think about it. How much time do we have to investigate in order to create a basic HTTP server on top of Node? You know, just to start playing with it without any fancy stuff, right? So including the full installation process, on average, it takes something about 1 minute. Adequately, how many lines of code we have to write down? Approximately 2 lines of code. Actually, we can just do it right now, right? Respectively, we initialize the Express instance, and afterward, we are just binding to the indicated port, right? Impressive, isn't it? 2 lines of code. So let's go even further and add a single root. Oh, up. Not excessively demanding, right? 1 single line of code. So if we assume that this trait, simplicity, comes from the amount of code that we need to write down to provide a certain functionality, perhaps it leads us to a conclusion already. And this conclusion might be the extent of complexity is plainly proportional to the lines of code. On this basis, let us arrange a mathematical equation, which is basically a linear function, y equals to x. This is a pretty simple visualization, right? Obviously, we are using here some abstract units of measurements. They are relative to each other, but we cannot explicitly define them. We've got a complexity on a y-axis and the lines of code on the bottom. However, this might be too general, right? Isn't it? This is a considerable simplification. It even looks unrealistic. So maybe the exponential function fits better here, since large code is mostly more complex and requires more overhead, more time to get familiar with. But the truth is that this thought is wrong as well, because this assumption would mean that the enterprise projects tend to be completely non-expandable, taking into account they quite often have got thousands of lines of code, right? Also, once again, it's not very credible. What about the code quality? We didn't factor that in, as well as a bunch of other essential factors, right? Anyway, this is a quite good simplification, so we will use it only for purposes of this presentation, right? So basically, Node is simple up to a certain point. The scaffolding process, the backbone arrangement, right? Initial design, prototyping, these are quite fast operations, right? 2 lines of code. Then we are just moving forward. And this is sufficient in most cases. Nevertheless, when the application becomes bigger, diving into the code in order to just fix something or find something or improve something, single functionality, becomes difficult. So let's imagine that you have to dig into the huge Node project, right? 2 years. Team was working 2 years on this project. And for example, you just recently switched the company and become a new member of the team. So you are pretty excited about that, just like everyone would be in this case. and somewhat terrified as well due to the incoming challenges. And you don't know these challenges. You don't know what you should expect. And this is what we typically feel afterward. A bunch of directories, their personal style guide, architecture, code conventions, new habits, everything is absolutely new, right? And this is a fairly common situation, and that's why the onboarding process takes so long. Though there are solutions. One of them is to pretend that everything is good, because let's say today is a Thursday, and tomorrow is a Friday, so we can leave the job, get some barbecue, meet with friends, and take a glass of wine, and this is how we usually look like that. We are leaving this quite messy stuff behind us. Now, we are not entirely sure that what we've done won't affect other elements of the system. But who cares, right? Because the design it's a crap. So it's not our mistake, right? We were trying our best. So the question is why? Why is it so hard? Because it was supposed to be easy. It turns out that the simplicity gradually disappears when it comes to a bigger and more complex systems. This characteristic is just no longer valid. Not because of the quantity of code, because we've got thousands of lines, but because of us, because of our decisions, people decisions. So generally speaking, projects heavily vary by people design decisions, right? And these decisions might be equally good, but completely different. And therefore, it makes them not very developer-friendly due to its incoherence. And when something is not developer-friendly, it's very likely that it is not business-friendly as well. So based on the current knowledge, let's take a step back to our chart with the exponential function. So our pretty fancy chart, this one, simple visualization, right? We might impose the other series depending on the architectural decisions, people decisions, design decisions, but it actually doesn't bring any intrinsic value. Furthermore, it's not very easy to predict. I would say that it is not even possible. That's why we use the simplification. Let us change the y-axis, the complexity, to the simplicity. And this is what we've got now. Another step is to put in the expected one. Instead of seeing something like this, we would like to see something like this, right? Much gentler, acceptable at any point of time. That is what we actually would like to achieve eventually. Slightly higher entry threshold in exchange for the less overhead in the future, for the scalability. You know, we have to think upfront, right? Not speed, but the velocity. Moving a little bit slower at the beginning, if that's necessary, but not thoughtlessly anywhere in the particular direction, right? Basically, we need to rethink our mindset. And this is exactly what we are going to do right now. First rule is split it down. What does it mean? So in order to understand that, let's take a glance at the typical application building block. Broadly, what do we use to build an app? In terms of the web apps, but not limited to, one of the most common elements is a middleware. Basically, the middleware acts like a proxy between the client and the request handler. Since we may have a sequence of the middleware, they might form a pipeline, right? The pipeline that determines the behavior of the currently processed request. And the idea that sits behind middleware is indeed quite good. We've got an ability to group functionalities such as authentication, compression, right, logging, and once implemented, reuse them everywhere, so tie them to the certain routes. But, however, middleware has too much applications, right? Meaning it has a wide range of responsibilities. In fact, too many responsibilities at once. We may use them either to mutate, transform, or validate the user payload. We may modify the request entirely. Additionally, we might create a side effects, perform some tasks asynchronously, or even end the request response cycle, preventing eventual handler from being called at all, right? So if it is a wrong approach, what should we do? And the answer is split it down. Split it into logical units. The element which takes care of the validation stuff is different than this one that performs side effects. Hence, it should be treated differently, named differently, and held elsewhere. From the design perspective, they are not equal. All these responsibilities, error handling, payload validation mutation, asynchronous side effects, access restriction, and so on, it is misleading to call them in the same way. Instead, your role as a programmer is to make it self-organized, well-descriptive, right? So anyone who someday will join your team will get it effortlessly. You will not have to explain all the stuff one by one. This person won't be forced to browse 100 of files, 100 of directories to find a particular functionality. Set the convention and stick to it across the full app. Another point is loose coupling. The goal of loose coupling is to reduce the risk. We want to avoid situations where the change made within one element will affect unpredictably the other elements of the system. Limiting interconnections isolates problems when things go wrong. It simplifies testing and minimizes needless interaction among components. But first of all, to even think about loose coupling, we need to define relationships. And regardless of whether they are solved by the functional composition or dependency injection with classes, we gotta keep them thin and clear. They should consist of the specified contract. In the case of the dependency injection, the inversion of control container becomes very helpful because it resolves bindings and reduces the amount of required boilerplate. Furthermore, it gives us a useful abstraction layer where we may explicitly define the usage of different instances of the particular class depending on the certain factors. For instance, in the testing environment, we may want to use C instead of B because, let's say, C does not require database connection, does not perform any heavy computation inside. And as soon as the interface is fulfilled, everything should work well without even modifying the internal implementation of these classes. Besides, decoupling things does not apply only to relations between components, but also to the entire modules. And as a module, we think about a couple of units collected together in order to solve a certain problem or provide a particular feature. The module should be literally a black box that exposes a facade to the outside world and abstracts the way how the things are implemented inside. It encapsulates the domain, and if that's possible, be completely independent of the transfer layer, thereby being truly portable across them. Such an approach to modules promotes organizing code per feature. And it is a very good rule in terms of the enterprise applications to allow, to keep order despite your app is continuously growing. I cannot even imagine the enterprise app organized by file types, right? So you are open the directory, and then you are just scrolling, infinitely scrolling because there is 1,000 of files, right? That would be quite ridiculous. In terms of the transport layer, the domain functionalities, domain-specific logic, they have nothing to do with the currently used transfer method. And as a transfer method, we understand things like HTTP protocol, gRPC, WebSockets, and so on and so on. The domain layer shall be portable across different transport layers, acts with absolute independence, and therefore will be able to reuse once implemented stuff and won't repeat ourselves. We will not create a mess by pointlessly mixing domain logic with the technical project requirements if we spend some time creating the right abstractions beforehand. The next thing is multi-layered architecture. This question mark isn't here by accident. And there are a couple of reasons for that. Nowadays, we try to create applications with a relatively good structure. Regrettably, we still may face architecture like this one, in which all business logic is inside a controllers layer, which in turn directly refer to the persistent layer. And regardless of whether the active record or repository pattern is used, or you use SQL database or no SQL database, it is still the worst-case approach. That is a very tiny sample code of really, really bad code that follows this kind of architecture. First step is to register the root handler using the application instance. And the next one is to select the organization user using the name. Just organization, sorry. So once we find the expected organization entity, we send a reply to the user, right? Quite simple, because it's maybe 2 lines of code. So recapitulating, I am unable to even identify what is worst, the strongly associated data access layer with the root handler, or this nasty imperative style. And we don't want this kind of ugly architecture. Therefore, we decided to create another layer, the service layer. So we took everything from the controllers and put it into the services, right? Except the, let's say, typical HTTP stuff, like the response management and so on. Excellent. Now we've got a clean architecture. Obviously, that is not true. One way of understanding where the problem is to look, for example, at the entities. Our entities, data schemas, they mostly have got few properties that describe them. We are basically specifying that, let's say, organization entity may have a name and may have a members. And let's think about it. The entities classes no longer have methods, right? Empty boxes for values. Once we remove the service layer, which basically contains everything, they are worthless. They just describe the data model. All the business logic is gone. Essentially, that's the difference between the entities and the models. At least, we should not expose everything publicly and breaking the main principle. It's not an ideal solution, but it's better than what we had previously. Instead, provide methods that describe in a trivial way what will be done inside, internally. The services will use data access objects to fetch and save the data, though the responsibility for validation business-specific operations and modifying data should be delegated to the models. Thus, we end up with self-describable data model, portable, and standalone. The next thing is be progressive. We don't have these problems like compilation, to make sure that our code is backward compatible with the old browsers, because we can just update Node, right? So the latest language features, recent libraries allow us to create more concise, testable, and legible code. With async await, we finally forgot about callback as well as promise chaining, of course, if that's necessary. Things like decorators, which are in the second stage of the ECMAScript proposals, enable metaprogramming abilities, giving rise to more declarative code. Let's look at the piece of code in the old-fashioned style, right? Something like this. And we're going to review this code step by step. Firstly, we need to define the user's root using the application instance. Hence, we post the callback. Then, we can call the final method of the user service instance. It returns a promise, so we have to call then. We have to call then method to pass the callback, which will be executed once the values are in place. Inside this function, we iterate by users and remove the password property, right? Because we don't want to expose it to the end user. And finally, we return a prepared users array. This code is illegible and difficult to test. Also, it is wrapped up in an imperative style, which makes it even tougher to understand. Let's try to achieve the same logic using the modern style, using the latest language features. We've got a decorator which responsibility is to automatically bind this method to the root in the background. Therefore, we got rid of the first callback. Next, we use async method, so we can await the promise returned by the final method. Afterward, we use built-in array methods to successively filter users and exclude password properties. In this case, the omit function comes from the loaders library. So we simply return the final result because we assume that the underlying framework, underlying library, will take charge of sending out the reply to the user. Eventually, we end up with the declarative code written in a functional manner, easy to test, and simple to understand. And the last chapter is types. As we all know, the JavaScript is dynamically typed language, which makes it extremely useful in terms of the scientific purposes and quick prototyping. Specifically, it makes coding faster, more concise, more tolerant to change, easier to hack, and much simpler to deal with, much simpler to learn. But the types are priceless, especially for the large systems. IDE autocompletion, compile type checking, but most importantly, the reduction of time that would have to be spent in order to understand the context of a given part of the code. Types gives us more information about what's going on. They also enable us to avoid simple mistakes at an early stage, like typos or flows in the order in which arguments are passed into the methods. Nevertheless, the statically typed languages, on the other hand, bring its own drawbacks, right? A huge amount of boilerplate is expressly slowing us down. We need to write more code, much more in the case of dynamically typed languages, right? Therefore, the optional typing system comes to the rescue and sounds like a best possible middle ground, like a trade-off. Personally, I really enjoy working with TypeScript, but it's not about the equipment, it's not about the tool, it's about the idea. Now, there is a flow, it doesn't matter. The type inference capabilities make possible to minimize the boilerplate, and at the same time, we can take advantage of all existing typing benefits, right? Sorry. Also, it's very crucial in terms of the enterprise applications when we may rely on the interfaces instead of concrete implementations of the classes. And also, we can get some context right away. With TypeScript, we are able to explicitly define the API of the module using interfaces. Consequently, we know the input schema as well as the expected output. We may tell the compiler, hey, we accept this set of properties, but this particular one, will lead to errors. No one needs to look at the source code, or even worse, in the documentation, to start playing with our module. Thus, sharing modules between projects in the company becomes much easier. So let's draw conclusions. Most of what I said, unluckily, boiled down to the well-prepared boilerplate, to the startup-based project, and the design specification, which outlines the architectural decisions to the rest of the team, so everyone will know what they should follow, right? Unfortunately, this is exactly what we are trying to avoid, right? I said at the beginning of this presentation, we don't want to have inconsistency. This indicates that what I said is a vicious circle. After collecting everything that I've mentioned, we are back to the beginning. The startup project and the design specification once again recall the problem of lack of cohesion. And the lack of cohesion means we are not developer-friendly. So how to solve this problem? And one solution which I would like to share with you is Nest. So at the beginning of this talk, I mentioned Nest. Basically, this is a progressive node framework for building efficient and scalable server-side applications. That's the definition. And actually, it is based on all these principles that I've just mentioned about today. Why? When Node came up for the first time, it was considered as an outstanding revolution. After a few years, the platform evolved substantially, albeit tooling wasn't good enough to compete with the mature technologies. Nest has been formed to bring code back by applying modern techniques and design patterns to the Node world. The main objective is to provide tooling, is to provide ecosystem. Nest varies from the other frameworks. It was born out of a strange idea to make our lives easier. Now, I didn't want to create another routing library or a huge wrapper around the existing small pieces of software and force everyone to learn the new API. No, we are the opposite, quite the opposite. Nest does not provide any built-in database, any authentication strategy. We don't have a bunch of modules that you may just plug in and use immediately. And finally, we don't make assumptions about what you want to build and how you would like to achieve that. Our goal was to preserve one single important Node trait, which is the flexibility. Even though Nest is a comprehensive framework, the entry threshold is still quite low. Basically, you are able to start playing with it using just 2 lines of code. What we need in addition is a single class that defines your module. We are like Webpack 4, the 0 configuration. And we are fully featured, which means we give you facilities to build web apps, GraphQL servers, REST APIs, various types of microservices based on the, for example, gRPC, NATS messaging platform, Redis, and so on and so on. Additionally, we provide testing utilities and useful abstractions that purpose is to help creating you scalable systems. We are reactive, meaning if you think about it, there are several variations of systems that actually operate on asynchronous data streams. For instance, real-time apps subscribe to the incoming messages and respond to them. Another example is a microservice that combines streams from different microservices and is successively forwarding them. That is precisely why core implementation of these features in Nest, WebSockets, and microservices is built on top of RxJS and works with it like a charm. So basically, you are able to return the stream directly from the function, regardless of whether it is a WebSockets application or microservice or REST API, and we will take care of the rest. And the next thing is compatibility. In terms of the web applications, Nest is compatible with both the most popular existing HTTP library, which is Express. Everyone knows Express, as well as with the Fastify, the rapidest one. We just want to reuse your knowledge. We want to reuse your experience. We don't want to force you to learn everything from scratch. It doesn't make sense. Have you built your app with Express? No worries, because you may gradually port your app step by step, feature by feature, because they are compatible. You want to stay with a fragment with Express? No worries. It's working. So, reassuming, we believe that your devs, developers, team, friends, anyone, while looking for issues in the code base, do not necessarily look like this guy, looking for bugs and issues. No? And even if you decide to employ new programmers, their quick jump into the code and onboarding process will not be similar. This one. Lastly, as I said already, Nest is open sourced, meaning we are like Webpack, we are like Vue, quite younger. We don't have too much months already. And we are totally driven by the community. And therefore, I encourage everyone who shares similar ideas to join this little revolution. We would love for you to contribute to Nest and make it even better than it is today. Besides, I would love to express my gratitude to all contributors, partners, backers, and companies that decided to support us so far. We are quite young, though. Anyway, we fully rely on the people and their support. So their support is, for us, admirable. Thank you so much.